Hi, how's everyone doing? Hope you're doing fine too. I'm starting a new series called Real Life Examples, and these are pertaining to merging engineering concept to real life, and because I feel like that's kind of a missing link when we learn these, when we're in these engineering classes. So this subject is called center of mass, and so we can talk about, whole physics of center of mass, two equations, and all that stuff, but the concept is a whole different thing, right? So here I'd like to talk about my personal experience with center of mass and how that plays a role with everything. So um, here is an example of a baby. And so right here, normally, well, the kind of background story with this is that my wife was telling me that the baby Aria that you see pictured would actually fall and hit her head, and we'd have to go to ER. And so her perception and my perception is actually kind of different. She's a mother, right? Mama bear, you can't mess with mama bear. But here, I'm just using, math and science, just facts. So here's how we discuss things. Well, actually, no. I've never discussed this with her because I would lose this battle, but this is my way of actually talking about it. So, in this example, the baby remains safe based on the support and center of mass. By support, I mean that the arms are right here, right? And really, the main supports are here and here. And center mass, normally it's around maybe the stomach or chest area, but we all know that baby's head weighs proportionally more. So we would kind of move it up a little higher. And so here's a free body diagram. It probably needs to be a little more there, but that's besides the case. Is that the way I see it is that this is your sofa, that's the baby, here's your free body diagram, and here's the center of mass, and that's the load that's going there, right? Totally stable, no problem at all. Okay. Now here, as you can see, the baby is getting closer to the edge. This is where the mom is freaking out like crazy. And I'm going, baby in my mind still remains safe. But how close to the edge can the baby get is a question. And so here, we this is Aria. We draw a again another free body diagram. You've got the sofa. Now here's where I guess this is where the perception is different, right? Is that Mama Bear looks at this hands and see that this can slip, and then all of a sudden the whole body's going to rotate, and we'd have to go to ER. But that's not the case, and this is what I mean. Okay. Now, even if this loses support, what happens is the body would kind of fall, and the center mass is still within the sofa area. So even though my wife sees this difference and thinking, "Oh my gosh, we have to go to ER," I'm thinking, "Well, no, it's actually from the center of mass, and so we still have that much distance to, as a factor of safety." And so now I don't have a photo of what would have it next because I don't think my wife would let me, and I do want to remain happily married. But this is really what's going to go on. Okay. Now what we have to be looking at is where the center of mass is. Even if her arms are off and the edge of support is right here, um, what that entails is that the gravity is force is acting this way. So you actually see that there's nothing that will allow the baby to rotate because that center of mass point hasn't passed this line. If the baby of center mass comes to the side of the blue line, this side, the baby will tip over because now what ends up happening is that if the mass is right here and this is what's happening, what you end up doing is that based on this, you create a moment, okay? And so that moment is what's going to throw off the baby, and then maybe we go to ER. But I don't know if you noticed, but in the photo, it's a padded ground. And finally, as long as the center mass is on this side of the blue line, the baby will be stable, right? Maybe, yeah, the baby's hands fall, but then as long as the center mass is right here, the baby will not rotate and fall, okay? And so here is kind of the unstable case where the baby would, fall, hit her head, go to ER, blah, 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 all this stuff, medical bills go up, up, up. into infinity. And so here is a case where here's your here's your kind of line of last support, here's your center mass, and so that distance, I mean, just imagine it was a little out more because it's pretty close, is that's your eccentricity. And so that's your moment, and that's what's going to take down the baby to the ground. But if you look at it, here's a photo, padding right there, not a big deal. Okay, and you can see that this sofa is pretty low. Again, not a big deal. Anyways, so in summary, here is the, okay. Now, how do we use statics to discuss this stability? It's just the formula for this is that moment is equal to force times distance. Or in this case, you want to make sure that the baby remains in a clockwise rotation. Here's your force, and here's your distance, and it's clockwise rotation. Okay, and really, you don't really have this true eccentricity because the body is just kind of lying there. But here is where it matters, is that once you have right here, remember the force is just acted by the gravity, and then you have a distance d, and so that would create a counterclockwise movement, while this one creates a clockwise movement. And so that's why it's important to know the sign of your moment. And so I tell my students, I don't really care about your positive, negative. I need to know if it's in clockwise or counterclockwise rotation. So, and so that is really the concept of force times distance, understanding, the clockwise and counterclockwise rotation. Okay, so kind of keep that in mind. Again, if you like these videos, or I can start a series of these where it talks about concepts and real life examples and putting it together so that engineers can connect the theoretical stuff that they learn from school and apply it to real life, right? So hit that like button if you guys really enjoy this, and I'll have more to discuss for everybody. If not, then oh well, I gave it a shot. Have a good one, everybody.